Jim here. I want to bring you up to date on my Alliance U-100 MCU controller. This is basically what it's going to look like. This here is a bud box. It's a 6 by 5 by 4. It runs about 20 bucks. This is an Adafruit display. It's an LED display. It's 1.2 inches high digits. The problem here is I'm thinking this is a pig in a poke because I'm wondering if it really will work. They do not specify anything about the clock of the I2C, nor do they specify how much current it draws at full illumination. So that to me kind of spells like piss poor engineering. But I'm willing to give it a shot and see what happens. This is the on-off switch, which is actually a push button. Off will be automatic power off after a 15-20 second period of nothing happening, and it will be done with a relay versus a solid state relay. The difference here between the two is this. Solid state relays do not completely isolate the mains from the load. And there's a piece of silicon in between it, and it's prone to leakage. Whereas a relay, when the contacts open, you do have a high impedance or infinite and no connection between the mains and the load. That's the difference. So I'm going to use a relay there. In addition, this is a optical encoder with a push button switch for the enter command. And this will run about $20, and it's from Gray Hill, I believe. Yes. And this is a 80 volt amp power transformer, which I believe will do quite nicely. Back over here now, we have the PC board. It looks like this thing is going to be somewhere around 5 by 4. And that should be it. And we also have 4 mounting holes for the mounting of the board to the front panel at the corners here. And this is a side view showing about where the front panel is and the board, and it's approximately 1 inch or thereabouts separation. So when we add it up, we have $20 for the transformer, $20 for the case, $20 for the Adafruit display, $20 for the optical encoder, which puts it in near $80 for just those 4 parts. Now the board will probably run anywhere depending upon the manufacturer. I'm going to look and see who's available for making a prototype, and we're looking at maybe $40 to $80 for this sucker. So let's say 80 bucks. That totals up to 160. Then another 40 or so dollars for miscellaneous parts. That includes the regulator, the capacitors, the microprocessors, some IC sockets. By the way, I'm going to do through hole, not surface mount, because I think through holes are easier, and not only that, allows replacement of parts easier than surface mount. So basically, I'm going to be using all through hole devices because they're still available. Then that just about does this what I'm thinking of. I've already started the software, and I've already started a little preliminary schematic. I'm handshaking the software and the schematic together so that they mesh real well. In addition to that, I've got a basic idea how big the board's going to be and what's going on the board. So that's why I've estimated it to be a 5 by 4. So it's not a fly-by-night thing. It's actually basically really close to what it might be. In addition, I'm making connections. I'm using some TE connectors, which I've ordered some samples of. And they'll be in the back for both the wires for the rotor, plus the power connector, not a power connector, but the cable coming in and connecting to the board into a connector. These will be push-in connectors, which do not require any special hardware for mounting pins or anything. And then with that, I'm going to do a few other things. And that's about it, a description of what I've got going right now. So there you are, what I'm going to be doing with this. Now, it's going to take me a while to do it, and the reason is I'm partially disabled. When you lose a leg, it's a little hard makes it walking down steps. Yeah, it does. And also my sight ain't so great anymore. By the way, I'm an old fart over 70 years old, so there you are. I'm not some dummy over here thinking about this. I've done this all my life. So that's what I'm considering doing. Also, I would like to mention this. If you use a solid state relay for anything, most of them will run you a minimum of 20 bucks. You can check that out with Mauser, DigiKey, Allied, Newark, or any of the other big distributor houses. And I'm going to do a little bit different. I'm going to use the processor to switch the triacs on and off. That's right. If I do the whole thing, that is azimuth and elevation, I would need 4 solid state relays. That's 20 bucks a piece. That's $80. Well, for $20, I can get 4 triac drivers, and be less than $20 and do the same damn thing. So why be a fool and go out and buy $20 parts when I can get all the parts for $20? That just makes sense. So there you is. And I hope give you an idea what I'm about to do, and we'll go from there. So I'm figuring maybe this is going to take me 6, 9 months, maybe a year to get it done. Because I've got other things to do, and I'm going to be working on this and a few other big odds and ends, and I do the best I can, even though I'm partially disabled. Thank you for listening. I hope this gives you an idea what I've got cooking. Somewhere along the line, it'll come out of the oven, and we'll have a video on that too eventually. So there you are. Have a good day, and thank you for listening. Bye-bye.